This tutorial discusses polysaccharides. The polysaccharides that we're going to be focusing on are ones that contain glucose. So this is a compound that takes hundreds of little tiny monosaccharides and links them all together. The first three are very, very similar. Amylose, amylopectin, and the glycogen. So let's take a look at amylose and amylopectin first. This is what starch is all made out of. In both scenarios, we have alpha chains. Now remember, alpha means that the OH is coming down. Beta means that the OH is going up. So in these, this takes up about, amylose is about 20% of what starch is. And they have alpha 1,4 glycosidic bonds. What that means is that you're going to see that V shape. On the first carbon, it's an alpha and it's bonded to the fourth carbon, the OH of the fourth carbon, which is always pointing down because it's glucose. The difference between amylose and amylopectin is the fact that amylopectin is branched. Amylopectin is 80% of the starch that we have. And so every once in a while you'll see on the sixth carbon another bond being formed, an alpha 1,6 glycosidic bond rather than alpha 1,4. The alpha for that first carbon, once again, the OH group is coming down and it's bonding onto that sixth carbon. Now the difference between amylopectin and glycogen is nothing more than the quantity. The glycogen is hydrolyzed in our cells at a rate that maintains the blood level of glucose and provides energy between meals. It's similar to amylopectin, but is more highly branched, so the branches are going to be more often. Now cellulose is the one that we're going to talk about, that's beta. Now remember the difference, alpha has that up-down, or down-up actually, whereas the beta actually has it coming up, and so it forms more of a straight line. So this is beta 1,4 glycogenic bonds, and we don't have the enzymes to digest this, so we can't break this straight chain down. So this right here, we can't break. It cannot form hydrogen bonds with water, thus it's insoluble. Gives a rigid structure to the cell walls in wood and fiber. So like in celery, that's what's consisting of the cell walls, is the cellulose. Is more resistant to hydrolysis than are the starches and cannot be digested by humans because we can't break down that beta bond. So look at the difference in the way it's shaped. Either way, that fourth carbon, the OH is coming down. That's because it's glucose. It's that first carbon that's making a difference. And that's beta, and beta OH is up, and it forms this line. And those are your polysaccharides.